Welcome to the second section of this course on algorithms and data structures in Swift. In this section, we're going to talk about computational complexity. In computer science, we use the term big O notation to describe the worst-case performance of an algorithm. Big O doesn't measure the speed of execution. Instead, it represents the number of operations made by an algorithm as a function of their input size. In fact, capital or big O is used because the growth rate of a function in terms of the input size is also referred to as the order of the function. Per definition, the big O notation is a mathematical model used in computer science to describe the efficiency of algorithms. I don't blame you if you think that sounds a bit obscure. So let me illustrate the big O through an example. Say we've got a list with the names from my favorite TV show, The Magicians. It consists of 5 names, 5 strings: Alice, Quentin, Penny, Elliot, and Martin. We can loop through the elements of the list to find an item. Here's the pseudocode. Loop through each name in the list. If name is what we're looking for, return name's position in the list. Otherwise, go to the next iteration. Let's assume that it takes 1 millisecond to check an entry. If we look up Alice, the search only takes 1 millisecond because it's the first element in the list. However, we need to check each entry to find Martin. Thus, the search now takes 5 milliseconds to run. If we had 100 different names and the name we're looking for is the last one in the list, the search would run for 100 milliseconds. In the worst case, the number of operations it takes to find a specific element grows with the number of items in the list. The running time of the search algorithm increases with the list size. With the big O notation, the performance of the simple search algorithm can be described as ON, pronounced as big O of n, where n is the number of elements in the list. In formal speech, you'll often hear it as O of n. You can even skip the O and say this algorithm is n. Big O doesn't tell us the execution time in milliseconds. Instead, it expresses how fast the running time increases as a function of the input size n. Big O can also be used to describe the memory or disk space used by an algorithm. We're gonna focus on the performance part in this course. I hope this video helped you understand the big O notation. If you want to delve deeper into code optimization techniques, algorithms, and data structures, I recommend checking out the complete course on Udemy. I included a link to the course in the description below. By the end of the course, you'll be able to write more efficient and reliable code. And as a bonus, you will also get a better understanding of how computers work under the hood. So, if you're ready to level up your skills, enroll in my Algorithms and Data Structures course now, and I'll see you in the first section.